Welcome to aminacademy.com. In physics, regarding gravitational potential energy due to gravity, let us do some solving problems. Look at this example. If the angular momentum of a planet is given by the vector L equal 5t 2i vector minus 6t j vector plus 3k vectors, what is the torque experienced by the planet? Well, the torque will be the same direction as that of the angular momentum. Here, that torque, we have to find that angular momentum is given. The angular momentum of the planet equal L vector equal 5t square I k vector minus 6t j vector plus 3k vector. Torque experienced by the planet is tau. Tau is differentiating this L vector with respect to t, that is tau equal dl by dt, that is d by dt, and substitute this L values. Now differentiating this with respect to t is 5t square is 10t, 10ti, then 60 differentiation is 6 minus that is 6j, 3 differentiation is 0, therefore k vector is not here, therefore torque is 10ti vector minus 6j vector. Here, next question. 4 particles each of mass m and equidistance from each other moving along a circle of radius r under the action of their mutual gravitational attraction. Calculate the speed of each particle. Here, 4 particles is placed here. Let it be A, B, C, D. The net gravitational force is equal to centripetal force. That means the force between A and B if is F1, A and B is F1. Now look at here, the distance here, radius is R, therefore this distance A to B is the distance is square root of 2 to R. Means the force between A and B is F1 is G, M and M, because all particles in same mass m, that is g m into m over square root of 2 r whole square. Then the force between A and D is also similar to g mm by square root of 2 r square, and the force between A and C, look at here, the force between A and C is 2r here. The distance A to C is 2r, therefore g mm over 2r whole square, F3. The components of F1 and F2, F1 and F2 along the radius is equal cos 45. That is F1 cos 45 and F2 cos 45, which is equal, because all F1 and F2 are equal to F. Therefore, net force is 2F, adding this one, 2F cos 45 plus F3, the force F3. Therefore, that means horizontal part along the AC is this one and another AC is F3. Therefore, net force is 2F cos 45 plus F3. Therefore, we are substituting G 2G m square over square root of R whole square into 1 by root 2, that is cos 40 value, plus Gm square over 4R square. Therefore, net force equal to centripetal force. Therefore, net force you are getting Gm square over 4R square into 2 root 2 plus 1, because taking common factor, which is equal mv squared by r. This is centripetal force. Therefore, from that speed we can find, from this speed is, after simplifying, we'll get 1 by 2 into Gm by r into 2 root 2 plus 1. This is the centripetal force by using this relation. Next question. Calculate the gravitational field at O due to three masses M1, M2 and M3 whose positions are given by the following figure. If the masses M1 and M2 are equal, what is the change in gravitational field at the point O? Here, three masses put in XY direction with equal distances A. Now, A, gravitational potential equal Gm by A square, and M1 minus M2 I vector, because it's horizontal places, plus M3 J vector. Two masses in same in opposite direction. Therefore, E vector is equal to Gm by A square, M1 minus M2 I vector, plus M3 is perpendicular M3 J vector. If M1 equal to M2 already given, so this value becomes 0. Therefore, it becomes E vector equal to potential will is equal to Gm by A square into M3 J vector. Look at here. This is because of M1 and M2. We are substituting here this 0. Therefore, E vector is Gm by A square into M2J. Next question. What is the gravitational potential energy of the Earth and Sun? The Earth to Sun distance is around 150 million kilometer. The mass of the Earth is 5.9 into 10 raised to 24 kg and mass of the Sun is 1.9 into 10 raised to 30 kg. Look at here. The distance between Sun and Earth are equal to 150 million kilometer. Converted to meter is 150 into 10 raised to 12 meter. Now, the mass of the Sun ms equal to 1.9 into 10 raised to 30, 10 raised to 30 kilometer. Here, 30 kg. The mass of the Earth me equal to 5.9 into 10 raised to 24 kg, which are given. The gravitational potential energy U equal minus G m Earth into m Sun over R. So 6.67 into 10 raised to minus 11, that is gravitational constant, universal gravitational constant, into mass is 5.9 into 10 raised to 24 into 1.9 into 10 raised to 30 over the rate distance between them is 1.5 into 10 raised to 12. After calculating, we get U is minus 4 in 4.985 into 10 raised to here. You can calculate this one, this 24, that is 54. 54 minus 11 is 30, 44. 54, 43 here. Yeah. 43 divided by 12 is 31. Around 31. Next here. Next question. An object is thrown from Earth in such a way that it reaches a point at infinity with non-zero kinetic energy. That means here kinetic energy R at distance R is infinity, which is equal to half mv infinity square. With what velocity should the object be thrown from the Earth? Here, that is velocity should be thrown this much ve equal to square root of 2g re plus h, because from the surface of the Earth that h distance, which is equal to 2g re, that h is infinity distance. So we have, therefore v equal velocity equal square root of v infinity plus 2g re. That is, after that we get this one. That much velocity you have to throw With what velocity should throw the thrown from the earth? This much velocity. Here, suppose we go 200 kilometer above and below the surface of the earth. What are the g values at these 2 points? In which cases is the value of g small? Here we have to compare the both g's. So first, the height above the earth is h equal to 100 kilometer, and gh you have to find, and re is given 6,371 kilometer. That is surface radius of the earth is this much. Then we know that gh equal to g into 1 minus 2h by re. This is a formula for gravity at any point above the earth. That is here. Therefore, g is g 1 minus 2 into h is 200 kilometer divided by 63700 kilometer, and which is equal 5971 over 6371 g. By using this calculation we get it this one. Therefore gh is 0.937 times g. Therefore gh equal to, at least for 2 decimal places, 0.94 g. The depth below the earth at d equal to 200 kilometer. Therefore GD what? R equal to 637 kilometer is given. Then GD formula is G into 1 minus D over RE. Now G is 1 minus 200 divided by 6371, that is equal G into 6 by calculation this one. G into 6171 by 6371. By simplifying we get GD is 0.968 G. Therefore, G for going down inside it is 0.96 G, go up is 0.94 G. So, go down is little more gravity than go up at same level distance. Now, let us do some conceptual questions. In the following, what are the quantities which that are conserved? Linear momentum or angular momentum of the planet, total energy of the planet, potential energy of the planet. Here, angular momentum of the planet and potential energy of the momentum are conserved, that is B and D. Here, the work done by the sun and earth in 1 year will be 0. Even how many years, there is no work done between sun and earth is always 0. The work done sun and earth at any infinite interval of time, any time, it is 0 itself, that is always 0 here. If a comet suddenly hits the moon and imparts energy which is more than the total energy of the moon, what will happen in this concept? If a comet hits the moon with large mass and with large velocity, may destroy the moon completely, or its impact makes the moon go out of the orbit. There's some chances there it is destroy the moon, or otherwise the moon will go some other places out of that orbit. If Earth's pull on the moon suddenly disappears, what will happen to the moon? That means the earth pull to the sun suddenly, suppose it disappear, what happened to that moon? If the gravitational force suddenly disappears, moon will stop revolving around the earth and it will move in a direction tangential its original orbit with the speed with which it was revolving around the earth. That means that revolving around the earth, so it starts to tangential to that orbit, so at the same speed. That means how it already revolved, that same speed it revolved, it not revolve, it go tangentially. Next question, if the earth has no tilt, what happened to the seasons of the earth? If the earth has no tilt, there will be no seasons like now and the duration of day and night. Both everywhere it is equal. The season is equal throughout the year if there is no tilt on the earth level. A student was asked a question, why are there summer and winter for us? He replied, since Earth is orbiting in an elliptical orbit, when the Earth is very far away from the Sun aphelion, there will be winter. When the Earth is nearer to the Sun perihelion, there will be winter. Is this answer is correct? If not, what is the correct explanation for the occurrence of summer and winter? Here, this answer is not correct. That means that Earth is elliptical orbit around the sun, so the season will not change because the season will change only by tilt of the earth. No, the season in the earth arise due to tilt, rotation of the earth around the sun with 23.5 degree tilt. Due to this 23.5 degree tilt, when the northern plateau earth is farther to the sun, the southern part nearer to the sun, so when it is summer in northern hemisphere, the southern hemisphere experience winter. That means regarding the tilt position of the earth, the season will happen to that earth. We have done. Please subscribe our YouTube channel.